Hello and welcome back to Calculus 2 section 7.3 part 2, the revenge of hyperbolic functions, meaning calculus. We are going to talk about derivatives and integrals, and as you have it from Calc 1, when you learn derivatives, you flip those formulas and you get your integrals right away. So we are going to run through the 6 hyperbolic functions, right? And then you will have for derivatives, and then you will have 6 integrals, so that's 12 formulas there. And that would cover hyperbolic functions. Then there is a whole part on inverse hyperbolic functions, definitions, graphs. So you technically restart the whole lecture for inverse hyperbolic functions, and then you add another, 6, and then you add another 12 formulas for derivatives and integrals and so on. So it gets to be a whole mess of things. But now we're just focusing on sine hyperbolic, cosine hyperbolic, and those cool things. Well, what is the derivative of sine hyperbolic? What would you guess? Yeah, right? So you would guess it's cosine hyperbolic. But then I say, you know what, let me work it out, because sine hyperbolic can be written as e's, right? So e to the x minus e to the minus x over 2, and you just take your derivatives of e's. So that's going to be 1/2 of e to the x minus e to the minus x times -1 in a chain rule. All of this mess goes into e to the x plus e to the minus x over 2, which is cosine hyperbolic x. In this fashion, you can work them all out. All right? All of them. So now I am going to write immediately 6 derivatives on the left and the 6 integrals, because they're just backwards, right? And then we can do some of the problems there. So derivative of sine hyperbolic x is cosine hyperbolic x, which means that the integral of cosine hyperbolic x is, where's my dx? Dx is sine hyperbolic x plus c. That's not optional. The derivative of cosine hyperbolic x is positive sine hyperbolic x, and the integral of sine hyperbolic x dx is positive cosine hyperbolic x plus c. You are used to have minus signs for trig there. Well, no more. Derivative of tangent hyperbolic x is, as you would like it, secant hyperbolic squared x. Integral of secant hyperbolic squared x dx is tangent hyperbolic x plus c. And now for the other 3, you have minus signs. The derivative of cotangent hyperbolic x is going to be cosecant hyperbolic squared x, minus cosecant hyperbolic squared x. Sorry. Negative. Right here. Get out of here. Negative. Integral of, no coughing, secant hyperbolic squared x. There we go. Dx is negative cotangent hyperbolic x plus c. Secant and cosecant left, they're all the same as trig. Derivative of secant hyperbolic x is negative secant hyperbolic x tangent hyperbolic x, and the integral of secant hyperbolic x tangent hyperbolic x dx is negative secant hyperbolic x plus c. Finally, the derivative of cosecant hyperbolic x is equal to negative cosecant hyperbolic x cotangent hyperbolic x, and the integral of cosecant hyperbolic x cotangent hyperbolic x dx is negative cosecant hyperbolic x plus c. And now we put the red box around this. These are your values. These are your values. And as you can see, apart from minus signs being off for two of the lines, the form of these formulas is identical to the form of trig, which is what you guys found in Calc 1. What's different? This line here and this line here. So you need to have opposite signs for trig. Everything else, same signs, and just remove h, and that will be trig. Cool. Now, I'm going to pick up one of these formulas because you rarely see the base example. Most of the time, you have chain rule for derivatives and U sub for integrals. 99% of the problems are like that. So, I would like to offer that improved formula for derivatives. And then for integration, you just have to do U sub. There's nothing else you guys can do. So let's pick on one of these, whatever. How about cosecant? Let's pick on cosecant. If you, no, I'm sorry, secant, hyperbolic, sorry, secant. If you have the derivative of secant hyperbolic of f of x, so now it's secant hyperbolic x squared, secant hyperbolic of square root of x, secant hyperbolic of ln x, right? So secant hyperbolic of some function, not just x. That's going to be negative secant hyperbolic f of x tangent hyperbolic f of x times f prime of x, because that's your chain rule. So that's how you're going to deal with if function is not just x, like linear, but anything else. You will have to copy the same function. You will have to copy the same function, right? Here and here, and then times the derivative. That's the chain rule part. That's the chain rule part. Let's take a look at hopefully a problem from homework where you are supposed to take a derivative or two. So let's do two of these, like a vanilla example and something spicier. Say the derivative of tangent hyperbolic squared x. Well, the derivative of something squared is 2 times something, which is tangent hyperbolic x, and then times the derivative of the tangent, which is secant hyperbolic squared x. Obviously, this would be something that we would call the basic problem. A bit spicier case. The derivative of, no, this is spicier, ln of secant hyperbolic of 2x. Double chain rule. It's not secant x, secant hyperbolic x, it's secant hyperbolic 2x. So when you take the derivative of that, that 2 is going to jump in front, right, as a coefficient from the chain rule. But then all of that is buried inside ln. So it's a double chain rule to solve this problem. Now, first derivative is ln, and we know that ln is going to copy the function as is in the denominator, and then we take its derivative in the numerator. What's the derivative of secant? Secant tangent, right? So we have secant hyperbolic 2x, tangent hyperbolic 2x, and times 2, a chain rule.
Is it negative?
Negative, yes. Thank you. These guys cancel. Very good. I really canceled that one. And you get negative 2 tangent 2x. I was about to put plus c. Terrible. Hyperbolic. 2x. Yes.
I don't know if I'm not seeing it somewhere written down here, but the integral for tangent hyperbolic x, what would that be?
Great question. How about you crank some U sub, you tell me. Perfect. I love the question. What is the integral of tangent hyperbolic? Not on the list because tangent x and tangent hyperbolic x are not basic functions for integration. So, let's go. Since you are interested, integral of tangent hyperbolic x dx, you know that you have to write it as sine over cosine hyperbolic. So go on, you sub it, and tell me the answer. What is u? Very good. By the way, this is one of the very frequent questions on the test, now that you used it up in the class, obviously, but there is also a secant, there is also, right? So u equals cosine hyperbolic x, du is? Positive sign, yeah. So now derivatives and integrals of these do not have minus signs. Right? If this was trig, you would have to have a negative sign, you have to go through all of that. But over here is just flat out. So our du is sine hyperbolic x dx, which is exactly what we have in the numerator. So this whole thing is integral du over u, which is ln absolute u plus c, which is ln of cosine hyperbolic x plus c. Is this the way we should leave it? No. We should follow the pairs, and even though you don't have a minus sign, you should make one up and then counter it just to turn this into a secant, right? So you can multiply this by a double negative and then use one of those two negatives to make a cosine into a secant. So this is negative ln of secant hyperbolic x plus c, just because we can. One problem from the book on integration, and we're going to call it quits. Here's a wonderful example. Lock the doors. Definite integral 0 to 4 fraction secant hyperbolic square of square root of x divided by square root of x dx. What? You actually don't have to write anything out. You should just answer the question. Secant squared is the basic integral, right? What's the integral of secant squared? Yeah. Do we also see that we have this root x? No, they don't. Square roots. You use a u sub, right? And you just have to figure out the constant, and then you plug in 4, 0, and you're done. So u equal root x, du equal 1 over 2 root x dx. I don't have this 2, so I'm going to install the 2. And I'm also changing my limits because I don't want to go back into root x. So u1 is the square root of 0, which is 0. And u2 is square root of 4, which is 2. So this is 2 integral 0 to 2 of secant hyperbolic squared u du, which is 2 tangent hyperbolic u from 0 to 2, that's 2, tangent hyperbolic 2 minus tangent hyperbolic of 0. Tangent hyperbolic of 0 is 0, and tangent of hyperbolic of 2 is 1 looking at the graph. So 2, 1 minus 0 is 2. That's it. With a minute to spare. So we end up early.
How many years of practice do you have?
Exactly.